Good morning, everybody. Thank you for the privilege of your time. I'm going to be talking about how we can make enterprise search work more like Google does, bringing that to the enterprise. But before I do, I just want to comment that even in 1512, Michelangelo knew that one day we would be collaborating in the clouds, except for this guy who's still struggling with his own infrastructure. Maybe he'll come on board one day. So yeah, I'm going to be talking about what Google looks like today and how we can use some of the technologies that they use in our enterprise search. And whether you like Google or not, they have definitely redefined what users expect whenever they come across a search bar. They want search to work just like Google. And in the 25 years or so that we've been implementing search solutions, I've heard this so many times. I just want search to work like Google. I'm sure many of you have either said that or have heard that from your consumers of your search products, whether it's an internal search or a search on a website. But what does that actually mean? I want to dig into what Google search is actually doing. And it's doing a lot more now than it used to a decade ago, right? Today, people are asking questions. So in this example, what is Tesla's revenue? We're asking questions, not just typing in keywords. And we're getting answers. We're getting answers from a knowledge graph. We're getting information on the entity card that's also coming from a knowledge graph. Of course, we have the search results. But in the middle, you're getting things like featured snippets, frequently asked questions, which is coming from a whole different technology. So there's multiple things going on here when you do a simple Google search. Most people don't realize that there's lots of things happening under the covers, but they are. And there's a number of different technologies that are at play here. Of course, there's the search that's been around for a long time, and Google search is great, very relevant results from straight keyword search. But there's actually a knowledge graph that's being incorporated here, and machine learning and AI. So this is what people call cognitive search, neural search. There's lots of different names for what this search represents today. Semantic search, you'll hear all these words, but it's essentially combining these three technologies to create the great user experience we have on Google. I'm going to go through some of these technologies just so that we can get a high-level understanding of what's happening. So NLP, natural language processing, been around for a long time, and it's fundamental in how Google is delivering those search results, right? Classic NLP has been based on ontologies, and there's different products out there. There's an open source product called Spacey, Amazon Comprehend, and there's plenty of people here who've been in the NLP space for a long time. But the most interesting thing that's happened around NLP is that it's now machine learning driven, right? You'll hear it. Vector search, neural search, all these different terms are being used for this AI-driven NLP. A few years ago, Google open sourced their BERT technology, which is a machine learning model that has been trained on 10,000 books, the whole of Wikipedia, and they open sourced that for all of us to use. That technology, BERT, is something that we can use today in the enterprise, and I'm going to talk more about that in a second. Using BERT and the traditional classic approaches, we can eliminate the ambiguity from meanings and many other things. These are just very simple examples of what we can do with semantic search. We can disambiguate what our question is actually trying to answer. So let's just take a couple of examples of what Google is doing and then maybe look to see how they're doing that, right? First thing we're going to look at is a question like this. How old is the moon? We get the answer back with some other information. This is actually coming from the knowledge graph. So this information is stored as what they call a semantic triple in the knowledge graph, with the information being connected via the relationship, and that's how you get this answer. Fairly straightforward, one hop from the moon to how old is the moon. Let's take a look at a more complex question. What is the age of the actor who played Neo's girlfriend? The answer is Carrie-Ann Moss, and she's 55 years old, right? We're so used to that kind of question and that kind of answer today that we don't really think about what's going on. But there's a lot going on underneath the surface of that question, right? So again, this is a knowledge graph answer. So first of all, we have to understand the question. We're looking for the attribute age. There's a relationship in this question. Finally, there's a person, and we need to try and find that in the knowledge graph. Now, Google's knowledge graph has Neo. We never mention Keanu Reeves in the question, but we know that Neo was in The Matrix, played by Keanu Reeves. He was born on that date. But Trinity was in the relationship with Neo in The Matrix. She was also in The Matrix. Carrie-Ann Moss played that character, and she was born then, and that's how we get 55 years old. So when you do that search, Google is going through this knowledge graph. I think 60% of searches and answers are coming from the knowledge graph when you do a Google search. But what happens if the knowledge graph doesn't have an answer? What if it's not in there? So here's another question, right? Who is better from these two amazing athletes? Well, you can ask that question, but it's very subjective. And so we're using a different technology to answer this. We're now using what we call extractive answers. This is where BERT, the model that was trained on 10,000 books and Wikipedia, has surfaced this paragraph from a document that says, hey, you know, Messi has the edge in scoring, but Ronaldo has different attributes. So it's kind of giving you an answer, but not giving you an answer. But it's coming from extractive answers. It's coming from the machine learning model. But how does this work? And I'm going to try and explain this simply, mainly because that's the level of my knowledge of this sort of thing. But extractive answers are also called featured snippets. When you hear about vector search, these are all the same thing. It's BERT applied to text. The great thing about BERT, by the way, is that it's not just been trained on English, it's been trained on multiple languages, and you can also add your own vocabulary to BERT, and we'll see how that plays in the enterprise. So here's another question that should have an answer. Let's say it's not in the knowledge graph. We get, which animal is the king of the jungle? Lions. But what's happening beneath that? Well, BERT has vectorized that question, but it's also vectorized every paragraph in all the documents we spoke about before. And these are the vectors that are represented by simple arrows here. This is the representation of it. And what's happening is we are looking at the vectorized question, and we're trying to find the closest matching vector that is in the machine learning algorithm. So lion is the king of the jungle is the closest to our question, right? So we're not using words, we're using ones and zeros to connect the question to this answer that exists in this corpus. If you were to look at the model of BERT, it's got millions of different lines coming out from that same point, and that's how it matches the questions when it's been trained on the English language. So that's how vector search is working underneath, alongside keyword search. So does this work in the enterprise? Obviously it works for Google, it's great, but does it work in the enterprise? And the answer is yes, now it does. And here's an example of something that we've done with the European Union and the Publications Office. Their charter is that they need to publish everything for citizens in the European Union. So let's take a look at a couple of questions that they typically ask. Like, what are the topics of Directive 2011-36-EU? You get search results. We implemented this search solution with Elasticsearch. It's good, it's got facets, you get relevant results. We've done all the right things to enhance the content so that you can find it, and you get good search results. But lately, what we did is we added a knowledge graph. Well, they already have a knowledge graph. So we incorporated the knowledge graph in the same way that Google does. So now, as well as those search results, we're injecting answers from the knowledge graph. So these topics are associated with that directive, right in the knowledge graph. So you're getting the answer right there. Now, the other thing that we've done is we've incorporated extractive answers. We've used BERT in French and Spanish and English, and we've added the EU's vocabulary to the machine learning model, so we can ask questions like this now. And the answer is not from the knowledge graph. This is from that vectorized paragraph in all of their documents. And you'll see here that there's 29.4 billion is the answer to this question. What's the annual global profit from trafficking humans? Now, that's embedded in that paragraph, but using NLP, excuse me, we can understand that that's a question, and that's probably the answer. So we can pull it out and actually say, hey, it's 29.4 billion. So that's a different way of finding an answer to a question alongside a search platform. So when we're building search solutions today, of course, we're going to use a search engine, and there's many good ones out there, commercial and open source. But we need to be thinking about adding some of these other capabilities to your existing search solution so that you can then have that Google-like experience. It is possible today, but the question we get asked is, yeah, but you need Einsteins to be able to do this. Well, the good news is that we don't, because Google has open source BERT, they've got the Einsteins, and they've put it in the cloud. And we have other capabilities that are available in the cloud for us to use, bring together, and create this experience. So at Pureinsights, what we're doing is we have created an orchestration platform. So we'll go to a customer and say, okay, you've got Elasticsearch, like the European Union, but we now need to bring in BERT. We now need to bring in your knowledge graph and bring it together. So we've created a platform that allows us to integrate and bring this stuff together to create that experience that you saw from the European Union. We have 3 lines of business: consulting. The technology is that platform that just brings other people's technology together, including open source search, BERT, knowledge graph. And what we're finding more and more these days is that many people build these search solutions. They're great, but search is never done. I heard that from one of our customers. It keeps going. You have to ingest more content, create relevancy, keep it relevant. Otherwise, users get dissatisfied. So we've created a managed service that we call Search Ops that helps our customers give us that workload. We'll manage it for you, and we'll help you maintain search on an ongoing basis and integrate some of these new great features. So in closing, I would just say that if you have a search platform right now and it's using keyword search, you should be looking at machine learning and knowledge graphs if you have them, bringing it together to really delight your end users with a search experience. I know we don't have time for questions, but I am on a panel with other people this afternoon. And so if you have any questions, be happy to answer them there. But in the meantime, thank you very much. And if you want to contact me, the information there.